This is number 1 from the 2004 exam. So we have traffic flow is defined as the rate at which cars pass through an intersection, measured in cars per minute, and the traffic flow is given by this sine function over here. And for part A, we need to figure out how many cars pass through the intersection over the 30-minute period. Well, this is the rate, so to find the number of cars, we need to take an integral from 0 to 30 of our function. We're going to use our calculator for that. And we are rounding to the nearest whole number, so that's going to be 2474 cars. Part B is the traffic flow increasing or decreasing at t equals 7. So we want to know if this function is increasing or decreasing at t equals 7, and the way we figure that out is from the derivative. Now if we find f prime of 7, we can do that with our calculator. You're going to get negative 1.872 or negative 1.873 depending on if you round or not. And since the second derivative is negative, we know that f must be decreasing. So since f prime of 7 is less than 0, okay. Part C, the average value of the traffic flow. So we're looking for the average value of f. So 15 of f of t dt. And again, this is something we can put in our calculator. You'll get 81.899, and the units of measure would be cars per minute, because that is what the units for f happen to be. Okay, D, what is the average rate of change? Average rate of change of the traffic flow. So the average rate of change is our slope of the secant line. So again, we're using our calculator to evaluate these functions. You'll get this number or this number depending on whether or not you round. And now f is measured in cars per minute, but here this is in minutes, so we've got cars per minute, or cars per minute squared.